Your next computer? Yeah, it probably shouldn't run Windows. I know. For decades, the traditional PC architecture has been the absolute, undisputed default for anyone wanting serious performance. But right now, there is a massive silent exodus happening in the tech world. Power users, lifelong PC builders, and creative professionals, they're literally walking away from the ecosystem they've spent their entire lives mastering.
The default era of the Windows PC is completely fracturing. We're seeing users who spent 10, maybe 15 years meticulously researching parts, building these massive custom water-cooled rigs, and tweaking systems suddenly just hitting a wall of absolute fatigue. They're abandoning the traditional operating system and the traditional hardware architecture entirely, and they're moving down two very distinct, divergent paths. Let's break down exactly what's happening.
Part 1. The Windows fatigue. Think about this for a second. You invest countless hours into BIOS tweaks, right? You apply the perfect layer of thermal paste, manage fan curves, and deal with these massive heat-generating towers. And your reward? You sit down to edit a video, you just move your cursor across an Adobe Premiere timeline, and boom, your fans start howling like jet engines while the whole system buffers. The friction of just using the machine has totally overshadowed the joy of building it. And honestly, a financial tipping point has been reached. The costs of traditional PC upgrades have skyrocketed to a level that is frankly absurd. If you want a modern graphics card with 32 gigabytes of VRAM to host local AI models or handle massive rendering workflows like, say, an RTX 5090, you're looking at dropping around $4,000 USD. Even stepping down to an RTX 5080 demands roughly $2,000 USD, and that is just for the card alone. The price-to-performance ratio? It simply no longer makes sense.
So users are waking up to this stark contrast. On one side, you have the traditional Windows PC. It's loud, it's hot, and it requires constant toggling between balanced and turbo power modes just to get work done, and you still suffer from buffering lag. But on the other side, you have the modern Apple Silicon Mac. Eerily silent, incredibly battery efficient, instantly responsive. You can sit in a quiet coffee shop, run heavy 4K video renders on pure battery power, and the machine doesn't make a single sound. For a lot of people, this isn't just an upgrade, it's a completely different paradigm of working.
Part 2. The hardware miracle. To really understand this hardware miracle, you have to understand a concept called unified memory. In the traditional x86 world, a computer's memory is aggressively segregated. You have your system RAM for your CPU, and you have entirely separate VRAM bolted on your graphics card for your GPU. Well, unified memory completely destroys that wall. It creates a single, shared pool of incredibly high bandwidth memory. And the magic here is that the central processing unit, the graphics processing unit, and the neural processing unit can all access this exact same pool simultaneously without duplicating a single piece of data. Let's look at the painfully slow traditional process. When you want to edit a high-res video or load an AI model on a standard PC, the data must travel from your storage drive, get loaded into your system RAM, and then, here is the absolute killer, it has to be copied and literally squeezed through a PCI lane just to get to the GPU's VRAM. Even with the absolute best consumer PCIe 5.0 lanes out there, you max out at a bidirectional speed of 128 gigabytes per second. It's a massive system-choking bottleneck. Let's break this down using a kitchen metaphor, because it makes the concept literally impossible to misunderstand. Think of traditional RAM and VRAM as two completely separate kitchens in a massive restaurant. The CPU is a chef in kitchen A, and the GPU is a chef in kitchen B. If the GPU needs the chopped vegetables that the CPU just prepared, those vegetables must be packed up into boxes, carried down a narrow hallway, which is your PICE lane, and then unpacked in kitchen B before any actual cooking can even resume. It is wildly inefficient, right? Now, contrast this with unified memory. Unified memory acts as one massive central kitchen island. The CPU, the GPU, and the NPU are all standing around the exact same table. They're chopping vegetables, seasoning the meat, and plating the dish at the exact same time. They're reaching into the exact same bowls without moving a single thing. Nobody is packing boxes, nobody is running down a hallway.
Part 3. The Zero Copy Advantage.
This logic is called zero copy, and it is an absolute game changer. Here are the direct, tangible benefits. Because all processing units have instant access to the data, that nasty PCI bottleneck is entirely eliminated. Poof, gone. And because data isn't being constantly duplicated and moved back and forth, the system's power consumption drops massively. That translates directly to no heat and no fan noise. This is exactly why a creator can scrub back and forth across a dense 8K video timeline, or a developer can load a massive local AI model with billions of parameters, and the machine doesn't even break a sweat. It just works. Instantly. Now you might be wondering, hey, aren't Intel and AMD trying to do this too? Well, yes, they are pushing new standards like CAM2 RAM, but there is a glaring difference here. Apple built both their silicon and their operating system from the ground up specifically for unified memory. Developers are forced to optimize for it. But over in the Windows 11 camp, the hardware is deeply fragmented, and more importantly, the Windows OS itself still stubbornly treats the memory as logically partitioned. So even if you have physical unified memory, Windows still forces you to manually allocate partitions in the software, which completely ruins the seamless zero-copy advantage.
Part 4. The Software Rebellion. So what if you demand freedom, but completely reject the closed, walled garden approach of Apple? Well, you pivot to Linux. And we have to dismantle a massive myth right now in this explainer. Linux is no longer just a text-based sandbox for hardcore coders typing green code on a black screen. Linux itself is just the core kernel. The distributions, or distros, provide the complete, beautiful, graphical operating systems you actually interact with. Today, 95% of your daily computing tasks are flawlessly supported right out of the box. Thanks to Valve and Proton, Linux gaming is no longer a joke. It's phenomenal. And surprisingly, features like HDR, which are notoriously broken and buggy on Windows 10 and 11, they actually work flawlessly on dedicated gaming Linux distros. No way, right? But it's true.
Part 5. Picking your perfect distro.
Let's give you a radically simple escape hatch right now. If you are an ex-Windows user terrified of culture shock, download Linux Mint. It has a familiar start menu, a classic desktop layout, and comes preloaded with all the drivers you need. It just works. If you are a power user or developer who wants phenomenal out-of-the-box NVIDIA driver support without fighting the terminal, go install Pop! OS. If you're a gamer, look at Bazite or Nobara. They are practically SteamOS clones that offer flawless HDR and optimized gaming performance instantly. And finally, if you're a hardcore tinkerer who wants absolute control and endless customization, Arch Linux is your sandbox. Just be warned, you will definitely need to know some coding for that one.
You know, the community sentiment surrounding this whole exodus is really profound. One user summed it up perfectly. Actually, because we are getting older, we just want to focus on work efficiency, compactness, and solving things definitively. Mac solves what I need: simple, compact, aesthetic, and durable. It really hits the nail on the head. The era of endlessly tweaking custom PCs, fighting driver updates, and battling fan noise is fading fast. Modern users are prioritizing pure stability, quiet efficiency, and most importantly, getting their time back.
And that leaves us with a final provocative question to ponder. Is the freedom of building a traditional PC still worth the friction of using it every single day? As hardware architectures evolve and open source software reaches incredible new heights of polish, the default choice is no longer the only choice. It's up to you to decide if your next computing environment will be dictated by old habits or by actual seamless performance.
If you enjoy this video, please like, share, subscribe, and hit the bell to the later update from my channel. Thank you for watching till the end, and see you in the next video.